Dear viewer, welcome to our program once again for today, your favorite program of Knowledge Quest on your favorite channel, Hope Channel Kenya. I'm glad to join you once again as we learn together. Our subject is physics as usual, and we are going to continue with the topic we were covering last lesson. It was measurement 2, and we did a portion of it. Probably today we are going to do the remaining part and we finish the topic. So I'm glad to see you, to join you once again, and I hope our God has taken care of you. So welcome as we learn together. So I'm your teacher, your usual teacher, Peterson Maranga, and I'm glad to be here for you this day and once again. So our topic, as we have mentioned, is measurement 2, and we are going to proceed from where we stopped in our previous lesson. So measurement 2, I want to remind you that in our previous lesson, last time, we talked about a few things concerning measurement 2. Measurement 2 has to do more with how we express the answers we obtain in the calculations. So in that previous lesson, that is last time, we discussed about a few things. Number 1, we talked about significant figures. That is, if you are given a calculation to do, you are going to express the answer according to a given number of significant figures. Then number 2, we talked about a standard form of writing the answers. And finally, we talked about how to write numbers according to given decimal places. So these are the components we discussed in our previous lesson concerning the measurement 2. Maybe to remind you that when we talk about significant figures, we are referring to the number of the digits which are appearing in the answer or the calculation that you have obtained. And so we said that significant figures are obtained by counting the number of digits starting from the first digit on the left, the first non-zero digit from the left. So you count all of them, they give you the significant figures in that given number that you have. For the standard form, we said that numbers are written in standard form when they are expressed in the form of a times 10 raised to power n, whereby our a is always between 1 and 10, meaning what? Your a can be equal to 1 or greater than 1, but strictly it has to be less than 10. So 10 is not part of what we consider when we are talking about that a. So when we express our answers in this form, a times 10 raised to power n, and our n an integer, then that answer or that number is said to be expressed in standard form. For example, for the standard form, let's have a number like 36148. This number is more than 10, and so it's not in standard form. We can express the number in standard form by doing the following. If it's a whole number, we said we are assuming the decimal point is after the 8, and our task will be moving the decimal point from that position so that it is between 3 and 6. So we are going to move it through 1, 2, 3, 4 steps. So we shall have 3.6148 times 10 raised to power 4, because we moved the decimal point 4 steps. 1, 2, 3, 4. And of course we said that when we move the decimal point to the left, the power of 10 is positive. So our n in this case is 4, and our a is 3.6148. So this number is written in standard form. We also discussed about decimal places. For the decimal places, we count the number of digits which are appearing after the decimal number, the decimal point. Decimal places only come into play when we are talking of decimal numbers. Remember, we have three types of numbers. We have whole numbers, we have decimal numbers, and then we also have fractions. So when you talk about decimal places, we are referring to decimal numbers, numbers which are written in the decimal form. For example, if we had a number like 3.6148, just like that, because of the presence of the decimal point, that is a decimal number. And now we talked about the decimal places. because we have 1, 2, 3, 4 digits after the decimal point, then we say the number is written to 4 decimal places. We can write that number to, say, 2 decimal places. That number becomes 2 decimal places. We count 1, 2, and then we look at the next number, which is 4. That 4 is not equal to 5. It is less than 5, so we drop it. The answer becomes 3.61. So this is written to 2 decimal places. That is what we were doing in our previous lesson, and we're going to build on that for the remaining parts of the topic. So I welcome you as we learn what we have for us today. So today we are going to talk about 2 measuring instruments that are used to obtain the lengths of given objects, or the diameters and the radius or something like that. So we have the following 2 measuring instruments that we are going to consider here. In Form 1, when we were talking about measurement 1, under the measurement of length, we said that length is measured using a measuring instrument that we called there a meter rule. A meter rule is what we said is used to measure the length of a given substance. But now, suppose we have very small lengths. For example, a very thin wire, or the thickness of a paper. We want to obtain the thickness of a sheet of paper. How do we go about it? I know that earlier on we must have talked of a way of approximating, that you take a ream of papers, you put them together. For instance, if we consider this book here, I'm holding a book. If we wanted to obtain the thickness of a sheet of paper like this one here, in Form 1, we must have said that we will consider a given number of papers. For example, the papers forming that book, I'm assuming because of the pages, they are 136 divided by 2, then these papers actually they are around 68 of them. So if we wanted to get the thickness of one of them, we shall measure the length or the height of all the papers inside there. Say it is 2 centimeters. So to get the thickness of one sheet of paper, because they are around 68, then the length of one paper will be equal to 2 centimeters divided by the 68 of them. So it will give you some answer. So that is what we discussed in Form 1, and that was our way of approximating. Here at this level, we have a measuring instrument that we can use to just, instead of us doing a calculation, we place that piece of paper between its jaws, and we can conveniently read the diameter or the thickness of that sheet of paper. So in this topic here, for these 2 measuring instruments, we are talking about very small lengths. We want to obtain the lengths which are very small, unlike what we were having in Form 1. There we were measuring the length of the school field, the length, the width of our classroom, the length from one place to another, which are relatively bigger, and we could use a meter rule. So at this level, we are considering much smaller lengths. For example, the thickness of a sheet of paper, of a piece or a sheet of paper. Then we are talking about something like the diameter of the hair. You pick or you pluck just one hair from your head, and then we want to obtain its diameter, or the diameter of a very thin piece of wire. So how do we obtain all these? Here we are not going to do the approximations we were doing in Form 1, and so we have the following 2 measuring instruments. The most important one of the 2, we have the micrometer screw gauge. So the instrument we're considering here, number 1, is the micrometer screw gauge. A micrometer screw gauge is used to measure very small lengths, and usually it expresses, or it measures the lengths in centimeters. So we have 2 micrometer screw gauges, as we have mentioned. We have those which are analog, that you have to go to the scale and you read. It's just calibrated like the meter rules, but there are 2 scales involved. And then we also have the digital micrometer screw gauge, though we do not commonly use them in the schools because they are not allowed to be used in the practicals, but they exist in the market. They are there, they can be used. I want to just take us through how to take the readings from a micrometer screw gauge. Once you have the object between the jaws and the scale has given you some reading, the thing is, what are you going to record? What do you put down? What do you read? And let me draw some diagram here to just help us to know what we do when we are given a micrometer screw gauge. So a micrometer screw gauge will be looking like what I have done, what I have drawn up here. And so there are two scales which are involved. We have a scale which is just like a meter rule. This scale here is straight, just like on a meter rule, and it's calibrated from a 0 in millimeters. And then we have another scale which is circular, and this one is having smaller or much smaller calibrations, divisions, like what I have here. Usually it starts from a 0 to around 45, all the way to 45. So if this is let me have my 0 here. So this is 0, 1, 2, 3, 4. This will be a 5, 6, 7, 8, 9. We could be having a 10 up there, but because it is circular, there are more divisions from behind there. Now, for us to get the reading shown by the micrometer screw gauge, we are going to take the summation of the two scales. We read this scale that is straight. We also take the reading of the second scale. We do a summation. Then it will give us the total reading, which is displayed by the micrometer screw gauge. Now, this scale which is straight here is called a thimble scale, and the one which is circular on the other side is called a sleeve scale. So the reading shown by a micrometer screw gauge will be given by what we obtain from the thimble scale plus what we obtain from the sleeve scale. Only that for a sleeve scale, whatever we read there, we shall subject it to, we multiply by 0.01, and this is called the least count for that micrometer screw gauge. Now, suppose we consider the example which we are having up here. If this is 0, the thimble scale will be, we just count the number of divisions we are seeing. This is 1, 2, 3, 4, 5. There are 6. 1, 2, 3, 4, 5, 6. There are 6 of them. So our thimble scale will be equal to 6 millimeters, because already the scale here is calibrated in millimeters, so the thimble scale reading is just equal to 6 millimeters, what we only see, excluding the 0 where we are starting from. So we are seeing 1, 2, 3, 4, 5, 6 divisions, and so the reading, the thimble scale reading is 6 millimeters. When it comes to the sleeve scale, now this one we're going to do it slightly different. We have 1, let me have my 0 down here. So this is 0. We have 1, 2, 3, 4, 5. For the sleeve scale, we look at the division which is coinciding or exactly with the horizontal line of the thimble scale. So if we count the division that is coinciding exactly, we have the 1, 2, 3, 4. It is a fourth division. Again, we do not count the first division which is corresponding to the 0. We start from the next one. So we have 1, 2, 3, 4. There are 4 of them. So our sleeve scale reading is equal to 4, then times the least count, which is 0.01. This gives us 0.04 millimeters. So then the total reading displayed by that scale of the micrometer screw gauge is the summation of the thimble scale and the sleeve scale. So we add these two, we'll be having 6.00 plus 0.04. This gives us 6.04 millimeters. So that is the correct reading which is displayed by the scale of the micrometer that we are seeing here on the board. The only important thing for us to note is that when we are taking the reading, we consider two scales. We have the thimble scale, the one which is straight, and then we have the sleeve scale, the one which is circular on the other side. So for the thimble scale, we count the divisions that we are seeing, the last division. So for this case, we have 1, 2, 3, 4, 5. The last one we are seeing is the 6th division. So we have 6 millimeters. But for the sleeve scale, we consider the division that is coinciding with the horizontal line, exactly coinciding. So if our 0 is down here, then the division coinciding with the horizontal line of the thimble scale is 1, 2, 3, 4, the 4th division. So that is why we have 4, but now we don't take 4 the way it is. We multiply 4 by the least count, which is 0.001. 0.01, so we have 0.04. That is the reading of the sleeve scale. So that now the total reading of the scale that is displayed will be 6 plus 0.04. We get 6.04 millimeters. Now, we have two scales. There are two possibilities of the micrometer screw gauges that we're going to obtain or to use in the practicals. Of course, not the digital ones, these ones which are analog. This is one of them. For the case that we have done what is displayed here, this micrometer is said to be having a pitch equal to 1 millimeter. Now we have another kind of a micrometer screw gauge which is having a different pitch, a pitch of 0.5 millimeters. Now for a pitch of 0.5 millimeters, something is slightly different there from the first one. Let me add something to what we can see here. For the one with a pitch of 0.5, there are lower divisions on the thimble scale, like what I have calibrated here. There are divisions on the upper part of the scale, and then there are divisions in between, two divisions of the upper scale. There is one below. This one and that one, there is another one in between, but on the lower side. This one and the next one, for each one of them, there are lower divisions. The lower divisions divides the thimble scale into smaller units. If this is 1, then in between, if we have a division, from the 0 to this division is 0.5. From this division to 1 is another 0.5. So that means if we are taking the reading from this kind of a micrometer screw gauge, we again take the last division we are seeing. So we have, this is 1, 2, 3, 4, 5, 6, but we are seeing the lower division as the last one. Now if this is 6, up to here this is 6.5. So the lower divisions will subdivide the upper units into smaller units of 0.5. So the last one we are seeing here is not 6 but 6.5. So now it changes. The thimble scale reading will be equal to 6.5 millimeters. Now the sleeve scale reading will remain the same thing. We shall be having the fourth division. So we have 4 times 0.01. This gives us 0.04 millimeters. So the total reading we sum 6.5 and 0.04. When we sum the two, we shall get 6 plus 0 is 6. 5 plus 0 is 5. Then there is nothing here. We have a 0 plus 4 is 4 millimeters. So for this one, the reading is 6.54. This is when we have a pitch of 0.5. For the first one, the pitch was 1 millimeter. There were no lower divisions. They were not there. And so we have those two cases, and when we be taking the readings, we have to consider if the pitch of the micrometer is 1 or 0.5 millimeters. Only to note that if it is 0.5, the lower divisions will be existing. At times you will not be told. As long as you see the lower divisions, then it tells you the pitch of that micrometer is 0.5. If you do not see them, the pitch is 1. And so we have the first case that we considered. Let me have this example for us. So obtain the reading that is displayed by the micrometer screw gauge scale shown below. Now suppose we have a micrometer scale like this one here. So I'm going to have only these two parts. This one is the main scale. So we have a 5 here. Then we have 1, 2, 3, 4. And then I have say 35. Then this is 1, 2, 3, 4, 5. 1, 2, 3, 4. This is 40. Then there could be more divisions, but those are not important. We are only interested with this division here. Now, again, this is calibrated in millimeters. The thimble scale reading for this one will be equal to the last division that we are seeing displayed there on the thimble scale. The thimble scale is the one which is straight. So if this is 5, then it tells us this is 6, 7, 8, 9. So that becomes 9. But because it is in millimeters, we have 9 millimeters. Then we also have a task of getting the sleeve scale reading. For the sleeve scale reading, we need a mark or a division that is coinciding with the horizontal line of the thimble scale. That division is this one here. So if this is 35 and that is 40, then if this will be 36, 37, 38, 39, then we have a 40. So we have 36, 37, 38. So we have 38. But now we multiply this one by the least count of 0.01. This gives us 0.38 millimeters. That is the sleeve scale reading. We sum the thimble scale reading and the sleeve scale reading. What does it give us? So we have 9 plus 0.38. This will be equal to 9.38 millimeters. That is the reading that is displayed by the scale of the micrometer that we are having here. As a student, it's only for you to know that for the micrometer screw gauge scale, it doesn't have the calibrations like what we have on the meter rule. On the meter rule, if this was 5, then we will not have this as a 9 because there will be some smaller divisions. This will be 5.1, 5.2, 5.3, etc. But now for this one, we count the divisions in parts of 1. So this is 6, 7, 8, 9. The other divisions, the smaller ones, we go to the second scale, the sleeve scale. But now we multiply by the least count. That's why we have 0.38. We take the summation, we get 9.38. Now, at times, the micrometer screw gauge may be having an error. An error simply means when there is no object in between the jaws, the micrometer displays a reading. You have not placed an object between the jaws, but the micrometer screw gauge is already showing some reading. We have two types of errors for a micrometer. We have a positive 0 error. We also have a negative 0 error. So errors occur when there is a reading displayed in the event there is no object between the jaws of the micrometer. So we have number 1, a positive 0 error, and then we have number 2, a negative 0 error. Now, how do we treat these 0 errors? Many times it is important for you as a student, before you use a micrometer screw gauge, say in a practical, it's good for you to know whether it has an error or it does not have an error. If it has an error, which is it? Is it a positive error or a negative error? Positive errors are subtracted. So if it is a positive error, we subtract it from the reading that we have obtained to get the final correct answer. If it is a negative error is added to the reading that we have obtained to get the final reading that we have read or obtained from a micrometer screw gauge. For instance, if this micrometer we have whose reading we have obtained here is known to have a positive error, say a positive error of 0.02, then the final reading will be this 9.38 we subtract. Because it is a positive error, positive errors are subtracted. We take the reading, then we do a subtraction. So the correct answer, if it was having that error, will be 9.38 minus 0.02. This will be 9.36 millimeters. Now, if the same is known to be having a negative error of 0.02, then for the negative errors we add, we shall take the same reading. Now we have 9.38 millimeters plus 0.02. This gives us 9.40 millimeters. So again, it's very good for us to know that when we are using the micrometer screw gauge, we first consider whether it has an error or whether it is not without errors. If it has errors, then we know which one. Is it positive error or a negative 0 error? Then positive errors are subtracted, and the negative errors are added. You take the reading just as we have said, the thimble scale reading, the sleeve scale reading, you sum them, then you treat the error as appropriate. We are going to go for a short break. I request that you stay tuned, do not go away. We'll proceed in a short while. Welcome back again. I'm glad that you are still tuned. You have not gone away. I'm glad to have you back. So we proceed with our lesson. Shortly before the break, we were discussing about the micrometer screw gauge, and we just discussed on how to take the readings from a micrometer screw gauge, and if it has an error, how to treat that error. We already mentioned that if the micrometer has a positive error, we subtract that error. If it has a negative error, we add that error. The error is treated at the end. You first take the readings as usual, and then you treat the error as appropriate. Many times as a student, the error will be disclosed to you. You'll be told the value or the size of the error, and so you take the readings as usual. You treat that error as appropriate. Now, that will bring us to the end for now concerning the micrometer screw gauge. I wish us to discuss the second measuring instrument that we have at this level, and that measuring instrument is called a Vanna Calipers. A Vanna Calipers. A Vanna Calipers is used to obtain the lengths of slightly bigger or larger lengths, unlike the micrometer screw gauge, which gives us room to measure very small lengths. Vanna calipers also exists in two. There are those which are analog, which have a scale like on a meter rule. You read and then you treat the different scales, and then you take the summation like for a micrometer screw gauge. We also have those ones which are digital, though these ones are limited in the practicals. So that is why we take some time in discussing on how to read from a Vanna calipers which is not digital, because that is what is common in the examinations. Just like in the other one, I want to have a drawing here of what we call a Vanna calipers, but again we're going to measure more on the scale, how to take the reading from the scale of a Vanna calipers. A Vanna calipers also has two scales, if I may draw. We have something like this one. There is a scale on the upper part that is calibrated like what, let me have this. So I have one, if that is a 0, then I have 1, 2, 3, 4, 5, then 6, 7, 8, 9. So for this one I have my 1 here. This is 1, and then this is in centimeters. Then in between I'll be having smaller divisions. I have a lower division, so 1, 2, 3, 4, 5, 6, 7, 8, 9. They are 10 of them. So the upper a micrometer Vanna calipers has two scales. We have an upper scale and a lower scale. The upper scale is called the main scale, and the lower scale is called the vernier scale. Now, for us to get the reading of from a Vanna calipers, we are going to take the total reading will be equal to the main scale reading plus the vernier scale reading. So that means we're going to read separately for the main scale, and we also read separately for the vernier scale. Then we do a summation at the end. Now, what do we do here? We do a very simple thing. Now, for a main scale reading, we are going now, it will force me to draw a different figure. Let me have this one here, so that I have a main scale up here. Let this be 2. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me have our 3 there. Of course, it could be extending to the right. Then we have the lower one having a 0. 1, 2, 3, 4, 5, 6, 7, 8, then 9. I have my 10 here. Now, for us to get the main scale reading, what we do is this. You look at where the vernier scale begins. Like on the diagram here, the vernier scale is the lower division. It is starting from this point here, then it goes to the right. For the main scale, we take the point to the left of where the vernier scale begins or starts. Listen, I'm saying that for the main scale, we take the point to the left of where the vernier scale starts. The vernier scale starts from here where it's 0 is. So the point to the left of that one is this division here. So if this is 2 and that is 3, then it means this is 2.1, 2.2, 2.3, etc. all the way to 3. So the point to the left of where the vernier scale begins is 2.1. So we shall have 2.1 centimeters. Then again we have the vernier scale reading. The vernier scale reading now, it is the lower scale. We have this one here. Now For the Vana scale, we are going to look for a mark that coincides with another division on the main scale, exactly coinciding. So if we look at this 0 here, this 0 is not coinciding with any division on the main scale. This one does not coincide with another division up there. This one does not. This one does not. This one coincides with that division. This one does not. This one does not. Etc. The rest of them do not. So then we have 1, 2, 3, the fourth division. So we shall be having 4, but this 4 is again subjected to the least count. So we have 4 times 0.01 centimeters. So the Vana scale is 0.04 centimeters. So that now the total reading displayed, already we said that the total reading is the summation of the main scale and the Vana scale reading. So we have these two summed together. So we have 2.1 plus 0.04. This will give us 2.14 centimeters. That is the reading displayed by the Vana scale that we are having on this diagram here. The only two important things is that for the main scale, we are going to consider a point to the left of where the Vana scale begins. Just that, wherever it is starting from, you consider a point to the left of it. That will give you the main scale reading. But now for the Vana scale reading, we need a division on that scale that coincides with another mark, exactly coinciding or intersecting with another mark on the main scale. From experience, usually when you make use of a Vanna Calipers, there will be that point. There could be one or more points that will be coinciding exactly with another point on the main scale. So for the Vana scale, then we take that point, but that point will be subjected to the least count. The least count is usually 0.01. Even for the micrometer screw gauge we were having earlier, the least count was 0.01. So we have 4 times 0.01, we get 0.04. We take the summation of the two, it gives us 2.14. Very simple thing. Let me have another example here. Draw. So still we get the reading that is displayed by the Vana scale. So this time round I'll be having something slightly different. So we have the horizontal line, that one. Let me have 6 centimeters. Then I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 7, then 1, etc. Let me have that point here of the 0. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is there. So the task is that we obtain the reading that is displayed by that scale. So we are as usual going to talk of the first thing. We obtain the main scale reading. The main scale reading we already said. We take a point to the left of where the 0 is, the 0 of the Vana scale is beginning. The 0 is slightly behind 6. So if it's behind 6, we are not going to take 6. We need a point to the left of that 6. The immediate point to the left of that 6 will only be 5.9. So we shall be having a main scale reading of 5.9 centimeters. Then for the Vana scale reading, we are going to look for that mark that is coinciding with another one on the main scale. The 0 does not, this does not, etc. It's only this mark which is coinciding. So we have 1, 2, 3, 4, 5, 6. The 6th division. So we have 6 times 0.01. This gives us 0.06 centimeters. So the total reading is the summation of these two. We have 5.9 plus 0.06. That gives us 5.96 centimeters. So that is the reading displayed by that Vana scale that we are having there. Again, a problem arises if the Vanna Calipers has an error. The Vanna Calipers can also have two types of errors. We call them the 0 errors of the Vanna Calipers. They can be two. Number one, we have a positive 0 error. We can also have number 2, a negative 0 error. Now, how do we treat these errors? The errors are corrected by the correction of the errors. Number one, the positive 0 errors are subtracted, just like for the other micrometer screw gauge we discussed, and the negative 0 errors are added to the readings that we have obtained. So there's nothing new here. This is what we mean, that if the Vanna calipers used to get the scale that is displayed here is known to have an error, then that error can either be a positive error or a negative error. There is no third option. There is either a positive or a negative. If the error is positive, we are going to subtract it. If it is negative, we're going to add it. But then we shall be taking the readings first, like what we have obtained, and then we correct that reading by treating the error. Now, if this if that Vanna calipers is known to have an error of, say, 0.01 centimeters, say this is a positive error, then the correct reading will be 5.96 centimeters. Because that is a positive error, we have a subtraction 0.01. This will give us 5.95 centimeters, as simple as that. If the error was a negative error of the same value, 0.01 centimeters, then the correct reading will be 5.96 centimeters, but now it will be addition 0.01 centimeters. So we shall get 5.9697 centimeters as the answer to that one, if it was having that negative 0 error of 0.01. So again, it's not enough for us to know how to read. It's also good for us to know how to treat the errors, should we be knowing that the calipers has an error. If we don't treat the errors and we use these calipers in the experiment, the error is going to be translated, it is going to be transferred to the calculations we'll do, and probably the accuracy is not going to be there in the values that we shall obtain at the end of the practical or the experiment. So we need to know how to treat these errors. Have it in mind that we either add or subtract accordingly, depending on which error that we will be having. Maybe I can give us an example here. That suppose we have the same, but now the error is given this way. Let us have the same diagram. We obtain the, suppose that scale was used to read the diameter of a marble, and it is known that the Vanna calipers has an error of 0.2 millimeters positive. And the question is, we obtain the radius of the marble, the correct radius of the marble. What shall we give as the answer? Because that is how now the questions come. The question says that the scale shown on the diagram here is of a Vanna calipers that was used to measure the diameter of a marble. Then the Vanna calipers is known to have an error of positive 0.2 millimeters. But now the question is, we get the radius of that marble. So what do? We shall first get the diameter of the marble. If we know the diameter, getting the radius is just taking half that value. So already but we can read again. So the diameter of the marble from the scale, we need the main scale reading. The main scale reading we said was 5.9 centimeters. Then the sleeve scale reading is 1, 2, 3, 4, 5, 6. So we have 6 times 0.01. We get 0.06 centimeters. So giving us a total, when you sum those two, of 5.96 centimeters. But now this has an error of positive 0.2 millimeters. Now look, the error is given in millimeters. What we have read is in centimeters. That means we cannot just subtract the 0.2 from 5.96. Of course, we know that the positive errors are subtracted. Yes, it is correct. But now this error is in millimeters. The answer we have obtained is in centimeters. So what do? We first change these millimeters to centimeters before we subtract from there. So as a student of physics or as a scientist, you need to know that if the measurements are not of the same units, you first make the units the same, convert the units before you do the subtraction. So it is easier for us to convert this one to centimeters because now the error the error will be equal to 0.2. In centimeters, we simply divide by 10. This gives us 0.02 centimeters. So that now the correct diameter, the correct value for the diameter will be equal to 5.96 minus 0.02 because the error was positive. So this gives us 5.94 centimeters. Now that is the diameter. We have not answered the question. The question requires us to give the radius of that marble. Of course, we know that the radius is half the diameter. So then our radius becomes 5.94 divided by 2. We take 5.94 divided by 2. What shall we obtain? This is use a calculator. 5.94 divided by 2. We have 2.97 centimeters. So that is the correct answer that is going to be marked if that is the question that was given to us. So again, it's good for you as a student to be very careful with what you're answering in a given question. Reading is not enough. Sometimes you can read correctly, but if you do not end up answering the question that is asked, you do not score anything in the question. Reading this way, like what we have shown here, is very okay, but then this is not the answer we are looking for. You have to read between the words used in a question, then for you to know what you are answering. At times, again, you can be required to obtain, this is a marble. A marble is spherical. A question can come that now, instead of you finding the radius, you get the volume of that marble. Now, for us to get the volume of a marble, the marble is spherical. The volume will be equal to 4/3 times pi times the cube of the radius. So we shall be having 4/3. Then pi is 22 out of 7. We have obtained the radius is 2.97. So we have 2.97. We cube that thing. It will give us some value. So that value becomes, let me do it here, 4/3 times 22 out of 7 times 2.97, the cube of that one. This is 109.7824 cubic centimeters. Now again, if it was in an examination, you may be required to express that answer to one significant figure, two significant figures, three significant figures, or in standard form, or to a given number of decimal places. That takes you back to what we started from. We started with in this topic, because we already discussed about the significant figures, the decimal places, and the standard form. So if this is what you not necessarily be answering, finding the diameter. The diameter will only help you to answer these other questions, like finding the radius or finding the volume, if that is the question that you are answering according to that particular question. So in the practicals, when we are using the Vanna Calipers, these questions are very common. Either you look for the radius, or you look for the volume, or any other question, not necessarily stopping at finding the reading that is displayed on the scale. So it at times requires you to go beyond what you have read to answering the question according to what the examiner wants to express on the paper. Again, that brings us to the end of this brief discussion of using the Vanna Calipers and the micrometer screw gauges. But what I can mention to you is, when we talked about the micrometer screw gauge and now the Vanna Calipers, the major difference comes here, that the Vanna Calipers is used to measure very small lengths. For example, the thickness of a paper. Just imagine the thickness of a sheet of paper. It is that small that you cannot use a meter rule to measure, the common meter rules. And so if we had a micrometer screw gauge, it can easily help us to obtain the thickness of that paper. Or if not so, we'll go back to what we did as an approximation in Form 1. But now in Form 2 and beyond, and in the practicals, we rarely do that approximations. We have to do measuring using this particular measuring instrument. So we had a micrometer screw gauge, and the micrometer screw gauge was measuring and giving us answers in millimeters. If not the case, then we are going to use Vanna Calipers. These two are very common in the physics practicals. So it's really our task as students to know how to use and how to obtain the readings from them, and how to do the calculations given the dimensions that you have obtained, and of course bearing in mind of the other things that we already discussed much earlier in this topic. Measurement 2 and by extension measurement comes to an end that way. I think the most important thing for you to keep reading is this. We had the standard form, and then we had the decimal places, and then we discussed of the significant figures. If you really are good in these significant figures, if you are good in this and the micrometer, screw gauge and the Vanna Calipers, then you are good to go in the practicals. And now finally we have also discussed about the Vanna Calipers, and we looked at on how to get the reading from a Vanna Calipers. We said that we take the main scale plus the sleeve scale reading, the Vanna scale reading. That should be a Vanna scale reading. So what we said is that you take for the main scale, you take the point to the left of the 0 of the Vanna scale. So we had like that one. Now a case may arise when we have more than 1 point coinciding on the Vanna scale, coinciding exactly with another mark on the main scale. For example, for the purpose of what we are doing, suppose this was here. Let me change that mark to that one, so that now we have, this is the 5th division, the 6th, the 7th. The two of them are coinciding exactly with the other marks on the main scale. Suppose we have such a scenario. What do we do when we are taking the reading from it? We consider the first mark that is coinciding. This is very important. You only consider the first and ignore the rest of them. So that if we have a case like that one, we have 1, 2, 3, 4, 5, 6, both 6 and 7 coinciding with the other marks on the upper part. We consider only the first one. Let me say only. So it will still lead us to the same reading that we are having there. Even if there were 3 or more points that are coinciding exactly, we only consider the first point that coincides. The others are just ignored. So that brings us to the end of our unit and our topic, measurement 2 and measurement by extension, because in Form 1 we discussed about measurement 1. I am glad to continue teaching you physics on your favorite channel, Hope Channel Kenya, and the program is the Knowledge Quest. Until next time, when we shall be making an introduction to a new topic, may God bless you, keep you, stay tuned, continue being blessed. Thank you for watching us.